Okay, so we're up to the last chapter, chapter 10 of Routing and Switching Essentials. So it's about device discovery, management and maintenance. So when it comes to discovery, there's CDP and LLDP we'll talk about. With device management, we'll talk about NTP for time synchronization, syslog for remote console messages, and so certainly useful for managing devices. And then maintenance, we'll talk about backing up iOS files as well as configuration files, and we'll talk about some of the licensing that goes with Cisco iOS these days. Okay, so device discovery, and so for many years now, Cisco has had its own protocol called CDP, Cisco Discovery Protocol, and so it is proprietary, so hence the C for Cisco. And so it's a layer 2 protocol used to gather information about Cisco devices sharing a link. And so periodically, each Cisco device advertises its details to other devices, and so it will share the type of device it is, its name, and its basically its capabilities and its addressing and other such things like that. And so you can use it to determine information about neighbouring devices to build a logical topology when documentation is missing. So that's exactly the purpose of it. And so CDP is typically on by default, and so if you do CDP run, that starts CDP on the device globally. If you don't want it to run on all your interfaces, you might actually do no CDP run to turn it off. And so from there, you can actually do it on a per interface basis, and so you can do CDP enable on an individual interfaces. Now, to show CDP neighbors, basically gives you a line of all the devices that have been discovered, and so it didn't find any here apparently. And so you can do show CDP interface to see its status. And so that's of use. Now you can also do show CDP neighbors detail, and that will actually give you a screen full of data as well. So here is a show CDP neighbors, and it gives you that R1 has discovered S1, so I'm assuming it's a switch. And so on R1 it's gigabit 0/1, and so hold time again is basically how long we will assume that device is still up, and so after 122 seconds of not hearing from it as far as CDP is concerned, it will actually clear its entry out of this info. And so capability means it's an S, S means it's a switch, and I means that switch can run IGMP, which is Internet Group Management Protocol, which is to do with multicasting. And so it's in 2960, and it's fast Ethernet 0/5 on that switch that is connected to gigabit 01 on this router. And so certainly good useful information, but as I said, if you do detail, you actually get pretty much a screen full of information on that device, and so it gives you IP addressing and the whole lot. So certainly of use, and yeah, the version of the operating system as well. So basically from R1 you now know that there's a S1 connected to it, and so you can then connect to S1, and then you can actually go, all right, well, what's connected to it? And so we already knew about R1, but now we're learning that there's another switch called S2. And so basically you can grow your map as it goes. And so, from the previous slide, it was R1. Well, you plugged into that. What's the rest? And so you can basically grow your map as time goes. And yeah, so you know what's plugged in. You even know what ports they're using. And so if there is no documentation to help you troubleshoot a network, this will give you that information. Now, As far as this is concerned, the only neighbour that S2 has got is S1, so there's no more Cisco devices on the chain to follow, so we've reached a dead end. And so, yeah, we've mapped the network. And so there was no information on R1 about any devices other than S1, so that's as far as we're going to get with CDP, but hey, it's all useful information. Now, as we said, CDP is Cisco specific. A vendor neutral standards-based version of it has been created called Link Layer Data Discovery Protocol, or LLDP, and so it's much the same as CDP, but other vendors do support it. I'm not sure how many other vendors, but it's open, and so it works with router switches and wireless access points, advertises identity and capabilities to other devices and information from a connected layer 2 device. So pretty much the same, but basically if you do it in global config mode, again, instead of CDP run, it's LLDP run. If you wish to do on a per interface basis, you can set transmit and receive. And so show LLDP neighbors, same again. So we got connected to S1, and so we can see that there's R1 and S2 connected to it. And so from that we can get the detailed information about addressing and other such things like that, and away we roll. So yeah, works the same, but yeah, more vendors support it. All right, so device management. And so first thing they talk about is the clock. Now the reason for this is when we talk about syslog later, it puts status messages on a server. But of course, unless you're sitting there waiting for those things to arrive, it's very useful to actually have a meaningful timestamp. So if you've ever noticed on your routers, the date and time is just depends on when it booted up. So it's not actually accurate unless you've done something else to do it. Now, managing, securing and troubleshooting and planning networks requires accurate time stamping. So date and time settings on a router or switch can be set using one or two methods. And so manually configuring it so you can actually set the time, but that's a pain, and you lose power and it's gone. And so NTP is an automated process. And so NTP uses UDP port 123. And so all you need to do is set up a NTP server, and then all your other devices can be NTP clients, and they can have a time that, of course, is consistent with that server. And so very useful feature. So, sorry, I didn't actually talk about that. So they're manually setting it. There's a command called clock set, and then you set the time, month, day, year. And that does work well, but yeah, it's not automatic. And if if there's a power outage and your devices reboot, they're going to lose that setting. So there's no CMOS clock that keeps track of time like on most PCs. So NTP. So NTP is a hierarchical system, and so basically when it comes to stratum, it basically means how sort of far removed is this server away from a trusted time source, authoritative time source. And so basically if it's stratum 1, it means that this particular NTP server is directly connected to an authoritative time source. And so those sources are often something like an atomic clock, or these days it's the sat-nav. So because time is very important for sat-nav, and so yeah, so that can be another source. Now, so stratum 1, of course, is a server that's directly connected. Stratum 0 is the actual time source itself. And so basically, if you have a server that gets its time from a stratum 1 device, it's stratum 2. And so basically, as you go down, and basically the highest useful stratum is stratum 15. If it's 16, it means it's actually not synchronized. So yeah, you don't depend on that. And so how do we configure it? And so you can actually have a Cisco device being authoritative, an NTP server, and that is certainly an option. And so, or of course you can have it as a client, which is what this setting is doing here. So we're saying the NTP server is at this address. You can use a host name as well. And so you can then do show clock detail, and it'll tell you what its time is, and it will say that its time source is NTP. And so if you did it prior to doing that NTP server, the time source is user configuration, and so someone had typed it in. So you can actually do show NTP associations, and so it tells you that it's connected to a Stratum 1 server, and it got its reference from GPS. And so so it's certainly good information. And if you do show NTP status, it says the clock is synchronized, it is Stratum 2, and it's using that address as a reference. So it's certainly good information. So this is also, we get good timestamps on our messages, which is of course useful if you're trying to track an event. So so here basically we've got the NTP server 192.168.1.1 and then end, and so so that's the server it's using, and its reference clock is from there, and so that's of course the upstream for this one. And so that's basically so we've got GPS is 0, the first server was Stratum 1, this server is Stratum 2, and then we've got another one that's using that's started Stratum 3. And so yeah, basically as you go down, yeah, every hop lower from that to authoritative time source, of course your stratum number rises. Now, so that's all good. So we've got time, and so we've got a meaningful timestamp, and so then we can actually look at syslog. So of course, you've noticed that when something happens on a router or switch, you actually get a message on the console saying that, you know, this has been done, and, you know, or, you know, if you hit shut down on an interface, you get a message saying, you know, the interface has changed status to down. So that's the types of messages we're talking about. And so, as I said, you don't want to be, you know, how often were you going to log into the console of your devices? Probably not that often. And so what you can do is you can actually have a syslog server, which will actually take in the messages from all these devices that you configured, and so we'll have it in the one spot. And so it uses UDP port 514, and so it sends event notification messages across an IP network to that message collector. So router, switches, servers, firewalls all can use syslog. So syslog service provides three primary functions: ability to gather logging information for monitoring and troubleshooting, ability to select the type of logging information that is captured, and the ability to specify the destinations of captured syslog messages. So the syslog protocol starts by sending system messages and debug output to a local logging process internal to the device. And so how the logging process manages these messages and outputs it is based on device configurations. Syslog messages may be sent across the network to an external syslog server and can be pulled into various reports. Syslog messages may be sent to an internal buffer, only viewable through the CLI of a device. And so destinations for syslog messages can include a logging buffer, so a RAM inside a router or switch, console line, a terminal line, or a syslog server. Now, basically, the default setting is a logging buffer, and then when someone connects to a console line, it will actually spit all the messages out when someone connects. Terminal lines normally don't do that, but you can say, you know, I wish to see the messages, and of course a syslog server is what we're talking about configuring now. So Cisco devices produce syslog messages as a result of network events. So every syslog message contains a severity level and a facility. So the smaller the number, the more critical are the messages. And so basically, if it's a level 0, it is an emergency, and so the system is unusable, and so it may or may not actually get to the server. But anyway, and so basically debugging is the lowest criticality, but also probably way too many messages. So it's something you ought to consider. So often you might go to, log at level 5 or level 6 or something like that, but yeah, it does depend on your needs. So each syslog level has its own meaning. So warning is a level 4, an emergency is level 0, error message is about software hardware malfunctions, functionality of the device is affected. Level 5, the notification level is for normal events, so an interface up or down transitions. System restart messages are displayed at the notifications level. Informational is a normal information message that does not affect device functionality. So when a device is booting, you might see the following information: end user license agreement, accept all. And then 7, basically, the messages that are output generated from issuing various debug commands. So that's going to be way too much information. So if you see a syslog message, it's going to have several parts to it. So it's going to have a sequence number, it's going to have a timestamp, it's going to have a facility, a severity, a mnemonic, and then the full description. So as an example here, this is the 46th message, and so it's got a link up down message, and so it's interface port channel change state to up, and so that's a sample for it. And so this is your mnemonic, and yeah. So by default, log messages are not timestamped. Log messages should be timestamped. So when sent to a destination, there is a record of when the message was generated. Notice the date below once timestamp is activated. And so you'll notice that you had a message come out here, but as soon as you do service timestamps log date time, you can see that it's now putting this extra information in the front, so it's a little more meaningful. Okay, so of course, the whole point of this is you've got a separate machine that's sitting there that's a syslog server. And so so this is showing Kiwi syslog server, and there's TFTPD will also do syslog as well. And so it's got an option. And so basically from there, it will then show that the messages have arrived, and so it's got a from address, the timestamp, and configured from console by console. So that's just saying that someone's actually gone in to config mode on that device and then exited, and so that's actually, you'll notice that you actually get that message on your on the console when you exit out of config mode, and so that's what it's done there. So it's a bit of an alert saying that, hey, someone's actually been into that router. Now, of course, that might have been valid, or it might have been someone hacking it, so at least it gives you an indication. So as I said, by default, log messages are sent to the console. Some iOS versions buffer log messages by default too, and so the first highlighted line states that this router logs to the console and includes debug messages, and so that's level debugging, so that's all messages are going to be there. All debug level messages, as well as any lower level message, are logged to the console. The second highlighted line stated this router logs to an internal buffer. So there's the console and there's the buffer. And then the system messages that have been logged are at the end of the output. So with show logging. And so as you can see, they're the lines that have happened. So how do we make a router or switch a syslog client? So basically, logging and the IP address of the syslog server, and then you do logging trap 4, which is that severity level, and then logging source interface G00. Now the reason you would do that is so we'll always have the same source address, and so it will always be logged together. So these syslog servers will normally sort of organize them by IP address, source IP address. So if the network's in a bit of a strange situation where some interfaces are going up and down, you might actually end up with more than one source IP address for the for that. And so if you tell it to always use the source of the G00, it will always come out the same, and so it'll always be in the same list. So now we're going into interface, doing shutdown, doing no shutdown. So we turn the interface off and turn it on again, and then you'll see the messages that came from that. So you can do show logging, include change state to up, and so it will just show you when that's happened. Or you can do show logging begin June 12th at 22:35, and so you can see what happened there. Okay, so device maintenance. And so this is, I think, pretty much the last part of the chapter. Now, part of the router, of course, does have a file system. Of course, it's in Flash mostly. And so you can do show file systems. And so, of course, Flash and NVRAM are the major ones. These other ones are sort of more virtual, so they're more in RAM than anything. And so provides information such as memory type of file system and permissions, be they read-only or read-write. So if you're normally typically interested in TFTP, Flash and NVRAM, so NTP, is that on the list there somewhere? Did I say NTP? TFTP, sorry. There is TFTP, but we're not connected to a server, and so there's no meaningful information. And so a bootable iOS is normally located in Flash, so it has the star saying this is where it's going to normally boot from. Now, if you do DIR, by default it will normally give you a listing of the Flash. And so here we've got a whole pile of files. So depends on the version of the operating system, of course. And so there's actually an SSL client here and a secure desktop and things like that. So these are actually software you can download to do certain things on your device. And so there's also there's a SHTML page, and there's the config. And so basically, to view the contents of NVRAM, you can actually CD to NVRAM, and it will show you what's in there. DIR, much the same as the DOS command line. Command is the same as with the router, so for a switch it's not greatly different. So you've got Flash and you've got NVRAM, and TFTP is an option, but again, not connected. Now, backing up and restoring text files. So, of course, the most common text file we're talking about would be the config file. So on the file menu, you can actually choose a location to save a file. So after the capture is started, to execute the show running, we'll show startup config, and then we'll actually spit it out to that file, and away you roll. That is one way you can save the contents of your running or startup config. Personally find it fairly faffy, but anyway, it is an option. Of course, I normally just do show run and then copy and paste it in the notepad, but anyway. Now you do have to be careful with that, because show run, it actually shows you a page full and says press a key to, any key to continue or something along those lines. And so those lines will actually end up in the config in that file as well. So you've got to edit those out. A configuration can be copied from a file to a device. When copied from a text file and pasted into a terminal window, iOS executes each line of the configuration text as a command. At the CLI, the device must be set at global config mode to receive the commands from the text file being pasted into the terminal window. You've probably noticed me, I actually often do EN and then conft at the front of my text files as well, just so I don't have to type anything. And so that does work nicely. Backing up and restoring using TFTP is another option, and so you can actually do copy running config to TFTP or startup config, and so it will actually then ask you what's the IP address or host name of the TFTP server, and so you type that in, and then you wish to save the file, you're going to have to give it a file name with you'd assume with a host name in it. And so it said, well, it's R1 config. That might be good, but of course having a date on it, that's also good. So that might be a good plan. And then it says, you know, write this file to the server. So it's in square brackets. So if you hit enter, it will do that. And so it will transfer it. Config files aren't very big. And so, yeah, doesn't take long at all. You can use USB ports as well. And so our 1941s have USB ports on them. And so USB flash can hold multiple copies of Cisco IOS and multiple router configurations. So you can actually use the dir command to view the contents. And so dir USB flash 0 : and that'll show you what's in there. You might want to do the show file systems first to make sure it's USB flash 0. So, which is, well, of course, what they're showing now. And so that's its capacity, that's how much is on it. And so, of course, that gives you the name you need to use to get to it. And so, of course, you can then copy running config to USB flash 0. And so that's a way you can copy it. And that'll work nicely. So that's another way you can back up. You can do a dir USB flash 0. And more, of course, is a way that you can view the contents of a file. Okay, password recovery. Now, password recovery is required just in case, you know, maybe you've inherited a network and the previous admin didn't give anyone the passwords, and so you can recover the passwords. Now, you do have to reboot the router. Now, the only way you can do it is with physical access to the device. So you have to be using a console connection, and you have to have done a hard reboot. So in other words, normally power it off and then power it on. You can't do a soft reboot. So that's the protection, is that you need to have physical access to the device. And so that's why you should always have them in a locked place. And so with console access, a user can access the ROM monitor mode by using the break sequence, so control break typically, during the boot up process, or removing external flash memory when the device is powered off. Now, change the configuration register to 0x2142 to ignore the startup file. So that's basically, this is sort of like boot. This config register is sort of like boot instructions. And so adding this 4, it's normally 2102. If you do 2142, that bit set in there, because the 0x means hexadecimal, means you've set a bit to say ignore the startup config. That's what you're doing. And so from there, you can actually boot, and it will then actually prompt you, well, I haven't loaded a config here, so do you want to do setup mode? You would normally not do that, but anyway. And so you can actually boot up, and then you can go enable. Of course, because you've ignored the startup file, there's no password. And then you can actually load the startup config. So you can do copy startup config to running config, and that loads it. And so now you're already in enable mode, and so you're in. And so, of course, first thing you should do would be change the password to something you know, and then you change the configuration register back to 0x2102, which is, of course, now don't ignore the startup config. And so save the config, and away you roll. You've recovered the password. Now that's on the router. Switches have a different process. So switches, you actually have to, well, you need to power cycle the switch, but of course there's no power button on them, so you have to pull the power lead out and put it in, and then you actually hold that status button in until it's booted, and it actually says, you know, recovery mode is enabled, I think, from memory. Okay, now iOS files. iOS files changed greatly between version 12 and version 15. They didn't actually do a 13 or 14. And so with version 12, you actually had to get a different version of the file for a different feature set. With version 15, most iOS files actually include everything. And you just need to use a license code to activate these extra feature sets. And so IP base does include a fair bit, but not everything. But so if you wanted to use your router as a firewall, you can actually activate the security set. So it will do VPNs and firewalling and all kinds of stuff like that. Unified communication, of course, it'll support voice a lot better. And then there's the data, that's for a data center. And so you can actually have extra stuff for that as well. So MPLS, I think, is the big one there. And so basically you can actually turn all three on as well, but of course you're going to need a fair bit of RAM to run that. And so, as I said, so you need to have a license code to activate those. You also need to know the serial number of the device. So the license code actually refers back to the serial number of the device. So you can't just use that one license code on every device. You have to do it per device. So basically, when you get an iOS file, at least from Cisco, they will have a file name that actually tells you a lot about it. And so C1900 means it's a Cisco device, and 1900 is the platform. So it's a 1900 model router. Universal means it's one of those ones that actually has the feature sets, all of the feature sets built in. That's what they mean by universal. K9 means it actually, K7 or K9 means that it has encryption built into it as well. And so, you know, we've done SSH, so you actually, I think one of the labs actually told you need to have K7 or K9, and that's the indicator for that. And so where does this iOS run? In memory. Z means it's actually been compressed in this file, and so it uses the zip format. SPA is just the signature indicator, and then from there, 15, of course, is version 15 with a minor release of 2 and a feature release of 4. And then so basically there are different types of images, whether they're mainstream or feature updates. And so basically M, I think, means it's a mainstream build. And then file extension is bin, meaning it's binary. Now, you are allowed to have a backup of your iOS file. That's not a problem. And so it's actually good practice to have a backup copy of your iOS file. And so a TFTP server is, again, a useful thing for doing that. You can do copy flash TFTP, and it'll ask you a few more questions. And so you can actually transfer a copy of your iOS file to a TFTP server as a backup. And so it works nicely. And so, of course, you'd want to ping the server first to make sure you've got connectivity. And so after that, as I said, copy flash TFTP. It'll ask you a source file name, and so you need to supply that. So that's why you do the show flash, copy, paste. And of course, that's the address of the TFTP server. What file do you want to save it as? Because it's in square brackets, if you hit enter, it'll do it, and then it will transfer it. Now, output emitted, it's going to be a screen full of exclamation marks until it's finished. I think it's 1 exclamation mark per packet. So, yeah. And so you've got a backup copy. Now, of course, a way you can update your router to have the latest version of iOS is to actually do the process in reverse. And so we're using IPv6 here just to be tricky. And so again, ping it to make sure you've got connectivity. Of course, you need to download that new image file from Cisco. You need to have a support agreement with them to be able to do that. And so you do show flash, how much space is there? And so then, is there enough space to put this other iOS file in there, or do I have to delete the original? Or is there enough space full stop? So these are questions you've got to ask. So copy TFTP to flash, And so you supply the IP address of the remote machine, the file you wish to transfer, what you want to save it as, and it will transfer it down and then store it on your flash area. And so then, yeah, if it's the only iOS file on there, it will boot from that quite happily. If you've got more than one, you can actually do boot system commands to control the order in which they try operating system files. Okay, so this is what's coming now. Boot system, flash 0, and then you specify how to specify the file name, and that will actually be saved in the config file. You can also do a boot system command to transfer it from the TFTP server as well. So basically, you can have boot system flash, and that's great. If that file is corrupted, you can actually have another boot system command saying TFTP address and file name, and it will actually, I'm saying it won't download quickly, but it will actually, it won't boot quickly, but it will transfer it from your TFTP server, and then it will boot that file. And so that's certainly a good backup process. Okay, so as I said, there's different licenses for different features that you need. And so when you buy a Cisco device, unless you paid extra for these feature sets, you only get this IP base. If you wish the extra features, at the time of purchase, you can specify it, or later on, if you need it, you can actually then contact Cisco and get the extra license key. But you will need to supply the serial number, as I said. So basically, to upgrade the feature set, you purchase a package or feature, and you get a PAK, which is a product activation key. And so the serial number or unique device identifier is required. And so from there, you can you'll get a license file, you install it, and it will run that feature set. So how do we purchase it? So customers receive the PAK with the purchase that serves as a receipt and is used to obtain a license. The PAK is an 11-digit alphanumeric key created by Cisco Manufacturing. It defines the feature set associated with that PAK. As shown in the figure, a separate license is required for each package, so IP base, data, unified communication and security. And so, yeah, if you want to add more than one feature set, you're going to have to get more than one PAK. So unique device identifier is a combination of the product ID, the serial number, and the hardware version. So the serial number is an 11-digit number which uniquely identifies a device. The PID identifies the type of device. Only the PID and serial number are used for license creation. So this UDI can be displayed by doing show license UDI, and so away you roll. And so then from there, you can install the license. Permanent license is a license that never expires. After a permanent license is installed on a router, it is good for that particular feature set for the life of the router, even across new iOS versions. So that's installed on the device, and if there's a new version of that of the iOS file, you can install it and it will just keep running. So license verification, if you do show version, it actually tells you what ones have been activated. And so there's IP base, which is permanently activated, and security has been permanently activated as well, while unified communications and data have not been. You can actually do show license as well, and again it shows permanent and not for the others. You can actually turn it on for an evaluation. So license accept end user agreement, license boot, module technology package data K9, and then basically from there you can actually try it out. So evaluation right to use, and so in this case we've got 8 weeks and 4 days left of our trial period. You can back up the license, so you can license save command is used to copy all licenses in a device and store them. Save licenses are restored by using license install command. the command to back up a copy of licenses is called license save, and then you tell it where to put it. And so from there, of course, you could copy it off of the device onto, a TFTP server or whatever it might be. You can uninstall licenses as well. License boot enable sec9 disable, and then you can actually go no license boot module. Okay, so that's the end of the chapter, and so this is also the end of the course, the topics for the course. And so there is actually skills integration challenge for chapter 10, and that actually covers the entire course, so that's probably not a bad idea for you to use that. It's a good recap, bit of practice for the practical test. So that's useful. Of course, I will have a practice practical for you as well. And so in this chapter we looked at discovery protocols, so there was CDP and LLDP. We looked at as far as monitoring was concerned, we did NTP and syslog, so again, more useful tools. And of course, when it comes to maintenance, we looked at backing up configuration files and iOS files. We also looked at upgrading your operating system to a newer version, as well as activating licensing packages. All right, so that is the end of the show, and that's the end of the course. So just testing to go. Good luck with that. I'll see you later.